Okay, we're going to start off today with showing you guys how to balance equations. I know some of you guys have done it before, but we're going to go over it again today for those of you that already have had it. And chemists use these statements called equations to represent chemical reactions. And each of these chemical equations has reactants, which are the starting substances, products, which are the substances formed in the reaction. That's what happens after the reaction takes place. And oftentimes we have to go from word equations. We have to have the words and we write an equation from it. And in this one we have solid aluminum and bromine gas react to produce solid aluminum bromide. And it's written symbolically as follows. You have the aluminum, solid aluminum is just by itself. The bromine is Br2 because bromine is a diatomic molecule. And the symbol here, the arrow symbol, it means it reacts, it forms aluminum bromide. Now this is just a skeleton equation. It's not balanced. The parts of the atoms on one side are not equal to the atoms on each side. Like we have one aluminum, aluminum and aluminum are good. But the bromines, right? There's two bromines here, Br2 and Br3 here, not balanced, okay? So we're going to show you how to balance these equations on the next one. We're going to talk a little bit more about the skeleton equations. They come from when you have a word equation, you get a skeleton equation. They have the compounds are correct in a skeleton equation. The Br2 and the Al Br3 is balanced, right? The bromines are always found in pairs, or halogens. They're always found in pairs. And the reason the aluminum and the bromine go together is aluminum has a +3 oxidation number. Bromine has a -1 oxidation number. So to balance that formula, we have to switch these coefficients, right? So that 3 comes down here and the 1 goes over there, and you get what we have here, AlBr3, where everything is balanced. The +3 on the aluminum balances out by the positive 3 times -1 on the bromine. And like the statement says here, that skeleton equations are usually not balanced. That's the number of atoms on each side don't match the atoms on the other side. The reactants and the products are not in balance. Coefficients are in a chemical equation. It's the numbers written in front of the reactant or product describing the lowest whole number ratio of the amounts of all the reactants and products. And we use these coefficients. They're just numbers that we use to balance the skeleton equations. Now, oftentimes we have problems where they give you the skeleton equations and it's already given to you and you just have to balance it. If they don't have a word equation, we're going to practice some of those at the end of this lesson where you have the skeleton equations and we're just balancing them out. So you always use the coefficients, the whole numbers in front of whatever compound or element is in the reaction. And the big rule here is to never change the subscript in a compound or formula to balance the product, okay? So in like that last one we had Al plus Br2, it went to form aluminum bromide 3. Okay, so you could never just take the bromine and go, okay, well, that's 2 is not going to be balanced, so I'll put 3 of them there like that. Bromine doesn't come in packs of 3. It only comes in packets of 2, so you can't do that in the formula, in the formula to balance the equation. It's tempting, but you cannot do that. So that's a big no for doing that. So it's tempting sometimes to do that, but resist that temptation. Here are the 6 steps for balancing chemical equations. The oops. Okay, sorry about that. 6 steps for balancing chemical equations. Skeleton equations, unless you start with some kind of word problem, the skeleton equation is often given for you. Then you need to count the atoms of each element in the reactants and do the same thing, count the atoms of each element in the products. Then change the coefficients to make the number of atoms of each element equal on each side of the equation. So we're going to balance it out using the coefficients to balance out the atoms on each side. And we want to use the smallest number on the coefficients as we can. So you wouldn't, if you had coefficients that were 2, 2, and 4 in a reactions, I don't know, just whatever it is, A, B, and AB, just a reaction like this, just a general reaction, we'll say. This is nothing. You wouldn't use the lowest ones. You'd write A plus B goes to AB, something like that. This one didn't really balance out too well, but you get the idea of what I'm saying is you want to, if you have 2, 2, and 4 like that, you want to divide everything by 2 to get the lowest coefficients. Okay, so here's some examples of 3 examples to help to balance the equations. And they're pretty good examples. And the other thing I should mention is that when we have these polyatomic ions, like in this first example, we have the NO3, right? The NO3 here and the NO3 on the reactant side and the product side, that stays together as a group. It acts just like an element. It doesn't split up or go apart. Okay, so we're going to start balancing out this first equation here. So you can pause the video if you want. Take a minute to try these out for yourselves, and I'll go ahead and work them out. So if you want to stop the video, work these out, see if you can work them out. Yeah, go ahead and stop it. All right. Ready to figure out if we got them right or not, so I'll go work these through. Okay, so we have sodium on sodium here. I'm looking at the sodium first, the sodium and the sodium on the reactants and the products. Looks like we have 2 sodiums in the products, in the reactant side, I mean, and 1 on the product. I said that wrong. We have 2 on the product side and 1 on the reactant side. So we need to put a 2 in front of that. You may have to erase these. It's kind of a check and guess thing, and you'll get better at it the more you practice at it. But the sodiums are balanced out right now. Okay, the sodiums are balanced, and the 2 in front of this, the 2 in front of the NO3 means that I also have 2 NO3s, right? I have 2 sodiums and 2 NO3s. So these 2 NO3s are balanced here. 2 NO3s balanced here. Okay, so that's good. So I'm balanced with that. Now I check the lead. 1 lead here, 1 lead here, okay? 1 oxygen here, 1 oxygen here, fine. Okay, so I don't have to put any numbers in front of these, but if we normally don't do this, but I'm just going to put the ones there for an example to emphasize in this example that we have 1 lead on the reactant side, 1 lead on the product side, and everything is balanced there with those coefficients. Okay, so we'll try the next one, number 2. Pause the video here if you want, and you can work it out, and we'll go over the answer in a second. Okay, same thing here. We start looking at the silver on the reactants, and we got 2 silvers in the product. So we know we're going to have to put a 2 on this side to balance out the silvers. Okay, so let's leave it that. I can see there's going to be some more things happening here. Iodine is this one. This is I for iodine, silver iodine, and we've got the 3 here on that iodine. So the 2, I'm going to have to change that 2, right, to make it work out. So this one is going to be a little trickier because we have some extra things trying to balance out. So I have 2 irons here. I need 2 irons here, so I know I have to put a 2 in front of that. Okay, so how many, when I do that, that gives me 6 iodines, right? So I need to have 6 iodines. That gives me 6 in my products. I just balanced out the iron, and that. Created 6 there. So I need 6 over here on this side. So that's going to put me, I got to change that 2 to a 6. Now my iodines are balanced out, and my, I'll see what I can do with the silvers now. I have 6 silvers here. I have on this side, the silvers come in pairs, so I need a 3 times 2 to make 6 silvers here. So I have Ag is 6. And how many of these CO3s do I have? I have 3, right? I have 3 of those. How many do I have on the other side? The CO3s. I got 3 CO3s there. I got 3 CO3s there, 2 there. So it looks like it's balanced out now, right? And then I wouldn't normally do this, but I'll just do this for these examples. We put a 1 there for that. But normally we don't balance the equations with putting a 1 in there. I just want to do it for these practice ones to show you that there's 1 of this iron carbonate compound. 6, 1, 2, 3. We can't reduce that anymore. So all those are the right elements for that. Okay, number 3, you can try number 3. Is not quite as hard as number 2. Number 2 is a little tricky going back and forth like that, and that's often what you have to do on these equations, like check and guess. And when you balance one thing, it'll change the balance on another. Okay, so we have this hydrocarbon here, and we've got oxygen, looks like a combustion reaction. It's making carbon dioxide and water. Okay, so I want to balance out on this one, it's probably best to leave the oxygens last. On equations like this, on these combustion equations, it's probably one little trick you learn is to do the O2s last. Okay, and do everything else and then do that last. So let's balance the carbons out here first. Carbon, I have 2 carbons here. Carbons, I have 2. Over here, I only have 1, so I need to put a 2 in front of that carbon to balance out the carbons. I have 2 carbons. On this side, H's, I have 4 H's over here. And I only have 2 H's over here, so I need a 2 in front of the water to balance that. So H's, I've got 4 H's on each side now. And now I need to figure out how many oxygens I need. I've got 2 times O2 plus 2 times another O2, just another O, I mean. So that's 1, 2, that's 2 oxygens here and 4 oxygens here. So I need 6 oxygens in my reactants to balance out the 6 in the products. So that means I need to put a 3 in front of this O2 to balance everything out. So the oxygens, I have 6 on this side. Oxygens over here, I have 6 on this side. That's my check that everything, each element is the same and balanced. And so those are 3 examples, and we'll work more examples in class too, but that was just 3 to get you started on balancing equations. So that's it for the video lesson on balancing equations.